how to approach this aspect. Okay, so let us say that we are any civil engineering project which are going to start. Typically, an architect plans this project and a structural engineer designs this. Now we consider that there is a piece of land lying there, and an architect goes there and he says that I want to construct a beautiful bungalow here, or let us say I want to construct a school here, or I want to construct a hospital here. If you when he thinks like that, he actually imagines the entire structure. So based on the kind of structure that is proposed, he will plan, make the planning, he will plan ventilation, he will plan orientation, he will plan ventilation, he will plan lighting, and so on and so forth, in such a way that it becomes very beautifully planned or beautifully arranged. Now, structure engineer comes into picture to assist architect. What he does actually is, he also imagines loads, he imagines the capacities of the concrete that are required, and he designs accordingly. So most of this data or inputs are starting inputs are kind of our imagination of human mind, whether it is loads, material strengths, or planning, ventilation, lighting, take any aspect. Now, but then at the same time, there are two inputs which are real-time data inputs. Now, what are these two? These two are topographic survey and geotechnical investigation. We'll deliberately discuss first the topographic survey. What does topographic survey do for you? You can look at the plan and you'll see that what are the plot boundaries. How is my plot located on the ground? What are the outer limits or perimeters? Do I have correct north located, true north as well as magnetic north? And what are the variations in the ground levels? We call them contours. You know, all of you know that already. Then what are the natural objects standing there, like trees or water bodies, nalas, or any other thing, or maybe a rock outcrop somewhere, or there's a ditch somewhere, something like that. And then some man-made actually structures, like there might be a small room or a bungalow or a barn standing there. There may be electric pole, some other objects. All these are man-made. So the actual orientation, locating north, variations in ground levels, natural features, and the man-made features. These are what we actually look at on the topographic survey. But these are all above ground. Now we'll go to the next slide. And what does the geotechnical investigation do? On the other hand, geotechnical investigation will do entirely below the ground. Now here what happens is, at our given project location, what are the subsoil layers? What are the thickness? What is the thickness of each layer? Does the thickness of each layer vary within our property? That is what we can call as stratification contours. Maybe the thickness of clay is on one side is more, it goes on the reducing on the other side. The rock strata or the muram strata is actually at somewhat higher level. Maybe there is a ridge. Maybe the rock actually varies at low, high, low, or static sloping from one end to other end, and various such features. Then the engineering properties of these materials, the different soil layers, subsoil layers. Then the most one important aspect would be to determine the groundwater table. Where is the groundwater? Is the groundwater at the ground itself? Is it at 5 meter depth? Is it at 10 meter depth? Because this is a very important aspect, because in soils you will find it will tend to place your foundations very close to water tables. And last but not the least, the chemical contamination. How much of sulfate does it contain? Does it contain chlorides? If it contains chlorides, how harmful it is to the concrete and the reinforcement steel? There may be also possibility of high organic deposits. If the organic contents are there, it will tend to form sulfuric acid and other deleterious chemicals like chromium, strontium, barium, fluorine, and so on and so forth. Lead, not to forget the lead, and they can also, cause damage to human habitation. So the chemical contamination also becomes an important aspect. So we actually are trying to find out this data from the geotechnical investigation. So the topographic survey and geotech investigations are that way are two aspects which are the basic inputs. Now just let's casually compare these two things. One side is topographic survey, other side is geotechnical investigation. So in topographic survey, we can take, let's consider that we have a very flat ground we can take a 10 meter by 10 meter contour, or 10 meter by 10 meter spot levels. If you want to increase accuracy, you can bring it to 5 by 5, maybe 3 by 3, maybe 1 by 1, and plot contours at very small intervals of even 0.25 meters. What actually happens in case of topographic survey is that the survey can be very quantitative. It can be analyzed properly, and these all give you idea about how to do cut and cover and all that. And all the objects are basically visible above ground. If you look at the geotechnical investigation part of it, the number of points, investigation locations, points you will choose will be basically limited. You cannot have arbitrary number of high. Supposing I find something, some variation, I will not increase the number from 8 to 60 or 10 to 20 or just like that, not double it up, or not 4 times, do it 4 times because of variation. But that is, there's a limitation on number of points you can drill, or you can locate, or you can probe. Then, so the data becomes partially quantitative but majorly qualitative. And because most of the stratification is not seen before excavation, like when you start construction, you will take up excavation. In piling, you will not even do that. But then in this case, suppose you for placing the footing foundation, you will be seeing it physically. So that is mostly predictive. You will be guessing. You will be saying that I got this layer 1, 2, 3, 4. So at layer 3, I can place my foundation. So thickness of the layer 1 and layer 2 are say 3 meter, and then followed by another 2 meters.
Last
So
time
put
ऐसा
place your
हो गया था,
foundation
पर
at 5
चालू हो गया था
meters.
बाद में.
So that way it is
पासवर्ड
predictive. You
रिसेट
want to
किया.
guess work. You want to estimate. Okay.
हाँ?
So that is the difference in two things. So
मालूम है
why
तुम्हारी
should
वजह
we
से प्रॉब्लम है
actually
ये सब.
want to do investigation?
तुमने तो किया था सब.
That is a basic question one should ask themselves. So
तुमने ही किया था सेटिंग उसका ना.
let's look at maybe 50 years from now. We have before this
मतलब
time,
अभी तुमको
or even
निकालना
little bit
पड़ेगा.
more than that. In 1960s to 70s, a structural engineer went to site. His brother, he was forced to
नहीं
go
मैडम
to
क्या बोले
site.
थे पहले आप किसको बताने
They
का.
dug some pits
राजू
there.
को.
Then they asked him, boss, what is the SBC I should take for this strata? Now यहाँ पे अच्छा strata लग गया मुझे.
तो वो सॉल्व करो ना, अपडेट रखो ना.
soil, मुरुम लग गया है. So what is the value I should take?
अच्छा ये
So
बात अच्छी
based
कही
on
तुमने, बहुत अच्छी.
Experience of the
ये बात तुमने बहुत अच्छी
particular
कही
person
है.
and his exposure to that particular area, he would say I will take 20, 25
क्या?
because possibility is that somebody has designed the structure there and
But
it
क्या
has
बात का?
withstood without
हाँ?
increasing distress. It is
आवाज नहीं बजे
given
बिना
good
कर.
performance. So he'll say I will repeat the same.
हाँ.
So what will happen
नहीं तो हम
is
अपन के राजू भाई एक काम करते
this
हैं.
process actually completely
सुना
bypassed
सुनो ना,
investigation.
इतने दिन से
Now,
रोज जल्दी
is it
नहीं
the right thing
बराबर
to do?
चालू हो रहा था. आज
The
जल्दी
question
अगर आज
is,
प्रॉब्लम
if I bypass the investigation for
अभी
today,
11:30 बजे
what will
लेटर
happen
चालू
to
हो गया.
me
ये
is
6
the
चालू हो गया.
foundation may become unsafe or oversafe.
वो भी
Let's
उनकी लिंक
first
से, मेरी
consider
लिंक से
case
नहीं
of
चालू.
oversafe foundation. In case of oversafe foundation, what will happen is you will have a, let's consider that I have an actual SBC is let us say 40 tons per meter square or 400 kilotons per meter square, and I select that as a 250 kilotons per meter square. The footing size will be 1.5 times what is required. So that much of concrete has gone.
किधर है दिखाओ.
Steel has gone.
दिखाओ
That much
दिखाओ.
extra excavation I have to do.
दुआ का दिखाओ,
I have to
सर्टिफिकेट मिला है क्या.
invest much more money to start with.
तो लेके आने का ना
the
फिर.
structure will be safe. It will be oversafe. But then
अरे हम
the
लोग
kind
बराबर
of
करेंगे.
load that will go on, or
अपना
that
केदार
kind of
भैया है.
concrete and material consumption that will happen, labor, excavation, concrete,
तो अपन
steel,
बाजू
all that
सोडून
will
देऊया
go
ना
into
राजू
the
भाई.
thing will
पीछे छोड़
be
देते.
high on the higher side. Now nobody wants to do that. So what will happen is they want
नाही आता ते म्यूट करून ठेवले
They'll
आता मी.
say instead of
आता
400
चालू झालंय
actual
पण तुम्ही
capacity,
ऐकायला लागतं ना
you'll
मला.
say it is 600.
आणि मी
Suppose
म्हणेन
if
की
somebody
चालू
says
केलं
it is
तुमचा
600 and
भरर
designs
मोठा
for
आवाज
that,
भोंगा चालू
then
झाला.
the foundation becomes unsafe. If the foundation is unsafe, then with time, once you construct the structure may undergo
ये
distress.
देखो पासवर्ड भी
There will
रिसेट
be
किया.
cracks, there will be
तो भी नहीं हुआ
settlement,
चालू.
and the cracks will cause
इसको आज देखो जरा राजू भाई.
such
आज ये भी
incorrect
काम नहीं करूंगा,
choice of
इसका देखो पहले.
foundation will then cause operation and
अरे
maintenance
पर 2 मिनट
cost,
तो देखो
increase
इसको.
operation and maintenance cost. Not only that,
हाँ
if
तो वो
the
छोड़ के ये काम
settlement
करो
happens
पहले.
during the construction time itself, then you'll find
अभी
that
अरे यार
construction
केदार
time will
घड्याळ
also
सेल आणून
increase.
टाक रे बाबा.
So,
तिकडे 9:15
incorrect
वाजलेत.
choice of
एवढं लवकर
foundation
आलोय
will
आपण.
increase the cost
एवढं लवकर झोपा
and will also
काढवायला.
increase the prolong the construction time. In such case, my budget
म्हणून काय
meaning
मागच्या शनिवार पण
supposing
लेट आलेले
I
माहिती
want
आहे
to start a school and I have a deadline or I want a timeline
का?
that I want to start a school by before June of next year. Then if the foundation itself is incorrect, then my time will go forward. So the productivity of the proposed structure, occupation of school, occupation of hotel, occupation of starting of the
अरे अरे
mall or starting of the factory, all of them will go beyond planned timeline. If it goes beyond timeline, the
कळलं.
productivity or the returns for the structure
हा
are
मग त्रास घ्यायचा नसतो,
definitely
त्रास द्यायचा असतो.
much lesser, and the project goes in loss.
राजू भाई तर काय कामच नाही करत, काय बोलायचं.
Why this is the basic thing why I should do investigation. But then consider this: why I should really do investigation.
वो तो क्या बोलने का.
Then one more thing I want to tell you saw that the site location is not suitable for you. It is not. It doesn't have a good. It may not have good. It doesn't have a good view. It doesn't have a good drainage. It doesn't have, let us say, good founding strata. थोड़ा खड्डा करके देख लिया. Then you find that okay, not workable. If this is not workable, I did not buy the plot. I just gave up the location. Instead of that, now we do that choice actually has been taken away from us. We are now forced to use whichever site is available for many of prestigious projects. In which case, you will end up with having to accept the undesirable location. When you accept the undesirable location, the investigation becomes very, very important to select an appropriate and safe and economical foundation for the proposed structure. Okay. Now, one can ask, immediately people ask, what is the cost of investigation? Now, what is it to, how much is a typical expense? The cost of investigation basically is extremely small compared to total project estimate. Many times, and this is a way where the architect and structural consultant, structural engineer should put their foot down and tell client that this is a bloody must. You must conduct the investigation appropriately, not do it just for the
नहीं,
sake of
क्या मालूम कैसा
what you
विषय बोला है,
have,
समझ
just for the sake of procedure to be completed. Because MCGM will ask for some investigation report, data
अभी
report.
वो.
You should not conduct the investigation
हाँ, अरे
limited
वो
only to that. You
मतलब
should make
लॉगिन हो
sure
गया
that
और वापस
adequate,
अचानक इशू हो गया.
sufficient investigation is done to develop proper confidence
देखा था वो.
in geotechnical investigation as well as confidence which is required for structural engineer that whatever foundation I'm doing for this proposed structure, my structure is going to be safe. For a very large project, and let us say that I go for 20-30 buildings at
वो
a
भी blur आ
time.
रहा है.
It's a residential complex, so big outlay is there. I've got a big budget in my hand, so I can conduct the
तो
investigation.
नहीं दिखेगा, ब्लर आ रहा है.
Even then, even
रुको
if
ना,
I
अपन ये
do
होने दो,
liberally
देखते हैं
carry
ना.
out the
तब
investigation
तक तुम
program
थोड़ा काम
liberally,
करो, 2
I
मिनट के बाद
conduct
देख
trial
लेना.
pits, I
मतलब 2 मिनट
conduct
के लिए देख लेना.
boreholes, I conduct let us say pressure meter test, I conduct lot of specialty test also, let load test also, even static coal penetration test also. All of this basically doesn't cross the limit of 0.05%. The pie diagram what is shown there at the bottom, actually that 0.05 is actually not visible line. It is so small in the project. We have deliberately made it bigger to sort of emphasize this point. But then, if the data is not correct, then it has got a very high impact on cost. So, when you are selecting a geotechnical investigation agency, also make sure in your field when you decide to go, ask for a reliable geotechnical investigation contractor. The person should be reliable, reputed. Make sure that his work is supervised. Make sure that the data coming from the person is correct. I'm not saying reliable, I'm saying correct. Data should be correct. And only then selection of appropriate foundation system will save your cost. Otherwise, everything can go wrong. Because once foundations are placed, the rectification and the correction is very difficult and very expensive. Now, in detail, let's try to look for what are the objective of investigation. In the second slide, we saw roughly what does the investigation do us, give us the different soil layers and the variation and the so on and so forth. Now, what do they do? So, supposing I'm planning a structure, let's say any structure, let's say one hospital or one office building. Now, what is the first question a structural engineer will ask me? I'm a geotechnical engineer, so he'll ask me, "Mujhe foundation, where should I put my foundation? At what depth and with what SBC?" Now, this is something I have to select, or a geotechnical engineer has to select based on the structural requirement. So,
Shekhar sir,
Yes.
Sir, your screen is not visible, sir.
Oh dear. Okay. 1 second. Huh? Please wait. Please wait. It is suddenly not visible now.
Not yet, sir.
No, wait, wait. We are not started. Check. Sharing again. Thank you for informing.
Now it is coming.
Yes. Visible now? We'll wait.
Yes, sir. Yes, sir. Yes, sir. Visible.
So far, the thing has been sort of not a problem, right? Okay. Hello,
Yeah. Visible, sir.
Mr. Vivek, can we go ahead? Yes. Okay.
Yeah.
So
You
what are
can
the
go ahead, sir.
detailed objectives of investigation? So for a given structure, the first question I require is what is the depth of the foundation and what type of foundation I should select. That is a shallow foundation or deep foundation, and at what depth I should do. So to determine subsurface conditions, like what are the different layers, maybe filled up soil and then clay or sand or muram and rock and so on
हे
and so
जास्त
forth,
लांब नाही ना
and then determine the properties of each and every layer. Then find out what is the SBC of each stratum and what is the likely settlement of estimate. I'm saying probable settlement of at that given value of SBC or a given value of loading from the structure. In some cases, in some very good cases, the rock may have capacity of, let us say, 200 tons per meter square, or there is 2000 kilotons per meter square, but the structure itself is small, let us say 10-story building. So the loading may not be that high. So for a given loading, the settlement should be within the permissible limit. So other than that, so basic requirement is SBC and settlement criteria. But then what are the potential challenges, like it may be liquefaction potential, the foundation site may be sitting on an expansive soil, there may be corrosive conditions, maybe acid flow, there's acid overflow, or there may be very high chloride content, we are very close to seashore, very high chloride content, or there may be swamp, we are in the constructing a building in maybe Gorai, it was originally swamp. In the swamp, there will be a lot of orchids. So orchids will convert into organic deposits, and they can actually create a difficult situation for us. So all these aspects actually also have to be studied. Then typically for basements, actually we have to estimate lateral pressures. If you are placing a dam or you are placing a sheet pile, then seepage through the foundation also becomes very important. So construction of seepage nets and estimate of capacity is also very important. And then other than that, like you have industrial structures. In case of industrial structures, you have some let's say hammers or forging hammers or vibratory equipments. All the dynamic properties of the foundation start at that location. These are the objectives in detail for a geotechnical investigation. Now, how much investigation should I conduct, or what is the basis on which I can conduct this investigation? So the first thing is, what is my past experience of the given area? Let us say I am constructing a hospital in, let's say, JVPD road number 10, for example. So what happens there is, what kind of strata is there? I know. Then has somebody constructed a similar hospital there, or a mall-like structure there, or a hotel there? Then loading is going to be somewhat similar to that. So I can use that past experience. And in that given strata, in the nearby plot, has somebody done some borings? I can find out that data. I can use that material. Then what kind of structure we are planning? Is it a residential? Is it a shopping mall, office, a school, hospital, auditorium, public halls, like maybe temples or some other prayer halls, and so on and so forth. All these actually matter a lot because the column loads will depend on the spacing of the columns. The moment we have different kind of structures, for the different kind of structures, I have or we have defined separate column spacings. When the column spacings are different, load per column goes on increasing, and so the parameters required for you, SBC, settlement, permeability, durability, vibration resistance, and liquefaction will also start mattering. So all of these have to be put together, and this parameter required is a point repeated. We know that. And last but not the least, what is the equipment available to me? What kind of machinery is available? Supposing I am going into a very small place, then what happens? Can I do I have access for that machinery? Let us say I'm constructing a or want to build some bungalow at the top of the mountain or a hillock. Can I take my drilling machinery on top, or I have to do or put up only the trial bit there? What kind of test equipment can I take? Plate load test there, because the towing of the material access, if it is not available, then you will find that conducting a desirable test may not be possible. And last, also important thing is, for conducting such a test, do I have correctly trained, suitable manpower? Even that also matters a lot. So the extent of investigation will start depend on all of this. We'll go to the next slide. So the most common thing what we do for investigation is the boreholes. Now, typically what IS code says is like this. Now we are coming to brass tacks. Or basic introduction is gone. We are now going to investigation proper. IS code says that you should do 5 boreholes per acre. 5 boreholes per acre is a 4,000 square meter area for 5 boreholes. Say roughly 800 meters square per borehole is what is required. So number of boreholes can increase based on type of structure, loading and importance and variations and so on. What we have gone before this also. Consider a typical case of single building. मेरे पास एक छोटा plot है, 600 square meter, 500 square meter area, or maybe even 400 square meter area. So I should go for 2 boreholes minimum, because 2 boreholes will give me profile. It will show me if there is a variation. One borehole, typically one borehole is drilled for 800 meter square area. That is about roughly 25 meter by 30 meter square grid, kind of grid. 20 meter by 25 meter to 30 meter by 30 meter grid. And if the project area is much more than 900 meter square, the number of boreholes should increase suitably. And supposing I have drilled, let's say I've got a plot, 1000 square meter, I drilled 3 boreholes, I find variation in borehole number 2 and 3. Then in between borehole 2 and 3, I should do additional borehole in case I meet variation. Okay, now you can look at a typical layout. You look at the second, this RTR layout first. In this, in the given irregular shaped plot, the location of building is already planned and finalized. So what we do actually is we make sure that we have at least one borehole serves the site. So we have drilled one bore at the center of each plot. You can see each building. You can see those green dots there. You can building number A, building number B, C, D, all of them actually have been given one borehole. On the other hand, when the building is not planned or a project is not proposed, see the layout on the left side. It's once again an irregular shaped plot. So here the boreholes have been done, but on the grid basis. Let's say 20 meter, 25 meter by 25 meter, or 30 meter by 30 meter grid actually is plotted on the ground, and they have taken the locations of the boreholes at that grid. Simply to get idea of the variation across the plot, both directions, x and y direction, or north, south, and east, west direction. So this gives this also option, but here the building is not planned. Building will be planned based on the investigation data in second left hand layout. So how deep should I? What is the correct depth of investigation? Now you know very well. That a geotechnical data is required up to depth where the stress on the footing drops down to 10%. So consider that you can see the diagram on the right side. You have ground level and the footing has been placed. Let's say footing has been placed at depth D below the ground, and we have foundation of width B. The stress curve shows that at depth 2B below the foundation, the pressure or a stress increment reduces to 10% of the stress applied on top, which is a 10 tons per meter square, 20 tons per meter square, or 400 tons per 440 tons per meter square. It is 400 kilonewtons. Now that is a minimum required depth of investigation. So depth is typically 2 times the width of foundation. So what we say is minimum excavation depth. Sorry, the depth of the foundation plus 2 times the width of foundation is a minimum requirement. Many times what happens is you tend to put basement there, or when you start the borehole, you don't know at what depth you are going to place the foundation. For big buildings, now we'll say that I'll drill the first hole, I'll find out at what depth I'm likely to place the foundation, and supposing that depth turns out to be 5 meters, then depending on the size of the raft or the footings or the area that would be proposed to be covered, I will go Further, below that level, maybe that's why I said minimum excavation depth as defined by structural requirements such as plinth level and basement trap top level plus 2 times the foundation width below that level. Okay, now we'll go to next point. So to summarize this table actually can make add to the guideline for you. Henceforth, you might even take a snap of this or can put a screenshot. What it summarizes is this is my shall we say criteria. This is not a criteria which is there in any textbook. This is a criteria which I follow. So for ground plus 1 or 2 floors, they only trial bit will do very well. Trial bit being a very not expensive proposal, we say that we can do more number of trial bits at every 300 meter square. I've considered trial bit and can go up to first stratum or up to muram or up to water table. Then the third limitation is that supposing I'm doing the same thing in Ahmedabad or doing the same thing in Kolkata and I hit water table, then I cannot excavate below. So trial bit will stop at water table, it can stop at first stratum, it can stop at muram. First stratum can be muram. Supposing the building is say up 3 to 5 floors, then you resort or go to borehole. Borehole can be for one borehole for 800 meter square will do very well. But remember our condition of minimum 2 boreholes. Here, soil overburden plus 5 meters in the rock is the criteria. Increase the number of floors from 5 to 10. You'll find that you can do increase the spacing per unit area to 600 meter square area. Reduce from 800 we have brought it closer to 600. So soil plus 5 meter same criteria. Increase the number of floors from 10 to 17. The area covered by one borehole is brought down again to see this basically gives you more and more confidence and more data. That's why it is required. So soil plus 10 meters and below above 17 floors, the new IS code 16700 becomes applicable and the criteria used for that is as below. From 18 to 23 floors, one borehole for every 400 meter square and soil plus 15 meters in rock or below founding level. That is the criteria you should use. And if it is more than that, let's say a very tall building, like you go for high-rise building, then I would recommend a borehole for every 300 meter square to get very good idea of the founding strata and what we should select. Next slide, please. So we have seen how much, where, what depth, everything we have done. Now we are coming to what are the types of investigations. The types of investigations are basic. Direct method, semi-direct method. Direct method is something which I can see the sample myself. I can visually actually go through and see the sample. In the semi-direct method, I extract the sample from given depth and then visually examine it. In case of indirect method, there is no visual examination possible. So there is no physical examination possible. So direct, semi-direct, and indirect method, and the other confirmatory tests. So in the direct method, we have trial pits, we have boreholes, soundings, and specialty tests like PLT, BVT, and DRIT. Now I will. Hello. Okay. Next slide.
Sir, you may continue.
ये
Hello. Hello.
बैटरी पावर का क्या बोला चार्जिंग स्टेशन बनाया था रखा है अभी तो देखा और हमारे
हाँ, sir, you may continue.
दुकान के अंदर रखा है
Shekhar sir, you can unmute yourself. Hello. Shekhar sir, you are not audible. Sir, you can unmute yourself, sir.
This was done.
Yes, sir. Now you're, yeah, yeah. Now you're audible.
No, somebody muted me actually. I did not mute myself. Okay.
Yeah, yeah, yeah. No, no,
Yeah.
there was some background sound, so maybe it has happened, sir. So you may continue, please.
Please, please. Thank you. Okay. So up to which point did you see me? Hear me?
Yeah, from this side, you were audible, sir.
All
You
right.
can continue from
So
this slide.
we are looking at second trial pit right now. Maybe it is
Yeah.
repetition, but we'll go ahead. So in the second trial pit, you'll see, or a better central trial pit, you'll see that there is a filled-up soil up to this point. There is an organic deposition which equally has become manifested into a black layer here. This is also filled up material. You can see brickbats here, and probably at the bottom you have virgin ground starting, and water table actually is seen very clearly in this case. And if you see the third one, in the third one, we can see a very small thickness of the filled up material up to this point, followed by natural clay sand soil, and there is no rock here, but there is no water table also. So these three different type of trial pits actually are deliberately shown for you. And the third trial pit we have depicted in the trial pit log. Say up to 1.2 meter we have filled up soil, and it is followed by yellowish brown loose clay sand. So this is a presentation, and the earlier one is a shall we say actual trial pit photographs. Both are actually presented in the report normally. Okay, we'll go to next one. In this case also you can see the method of excavation using JCB, trial pit number, date of commencement and ending, and the stratification actually is mentioned in this. Now these are basically site identifications. The samples are not tested. Okay, so we'll go to next slide. Okay, this is a kind of a for semi-direct method for a boreholes. I'm just giving introduction. Okay, look at this. This is a age-old drilling rig, soil boring rig called Calyx boring rig, which is a very basic rig, but it is very handy. Can be dismantled and it can be taken anywhere. It's a very lightweight material, but very sturdy, good for 50 meters. So this is one basic type of rig. A better rig actually is seen here. It is motorized. It is sitting on the tires and has higher mass. So longer rods can be used and better progress can be achieved with this. But this is also a rig very good for soils. See, this one has a long member here, standing here. You can see this is a drilling rod actually standing out here. The third one is, which is a new one, which is now slowly becoming more and more common in the market. This is a hydraulically powered drilling rig. Now these three things actually are the, shall we say, technological improvements. So why I'm suddenly introducing this, because in semi-direct method of boreholes we are going to use these things. In a semi-direct method, boreholes are actually done, and the main things that are done in the main samples that are collected in the semi-direct method is that you collect the sample at a given depth and then you visually examine its surface. So what are the things that are done? So my first one is a SPT, second one is UDS, third is a field permeability test. These three things we are going to see in this presentation. So you can see you drill a hole up to a certain point, let's say depth D, then you attach the SPT spoon. This is called SPT barrel. It's called split spoon barrel. You can see split spoon here. After you removing, this is the head and this is the shoe, which is put on this, and then this is after assembly. This is after opening that. So you go up to a certain depth, and then you start giving number of blows using the on the anvil. You drop 63.5 kg drop hammer. Now this is dropped at, let us say, 1 blow per minute. That is the speed, or that is the frequency, or shall we say frequency of dropping the hammer. So you do that, and you for first 15 blows, first 15 centimeters, number of blows are counted. They're called N1. Then second set of, for the second 15 centimeters, they're called N2, and third 15 centimeters are called N3. And the SPT value N is N2 plus N3, which is a SPT resistance N. Now this test, now somebody can sit down and ask, why has somebody selected 63.5 kg? Why is a drop of 750 mm used? Why is the SPT spoon of 45 centimeter used? Actually, the SPT spoon is total length is 55 centimeter. Now, why all these things are done is that this is an empirical test, has been done from time immemorial, right from the starting of the maybe 1850s, and this test has been used. And today, I'm using this word carefully. Today, the shear strength of the clay soil is actually established or correlated very closely with the resistance that is measured, SPT N value. SPT resistance is SPT N value or the below count with this empirical method. The method is empirical. I'm repeating the word. This is not arbitrary. This is not experimental. This is empirical method. So this empirical method is actually used for correlating the shear strength of the soil with the number of blows. So it becomes a very important tool to us. Next is UDS. When you have soft marine clay, particularly, you take a well polished tube which is chrome plated. These edges are beveled like this, sharpened, and you attach the tube to the rods, actually drilling rods, and push it down into the soft clay material. You can see the clay material here, which is there. You rotate the tube at the bottom and extract it. Here, for creating suction on the upper head side, you actually have a suction head, and you take it out. The sample comes out. Now remove small amount of this thing and pour a wax on that. Pour a wax on either sides to ensure that moisture is not lost. If you, let us say, I'm conducting a investigation in Bangalore or conducting a investigation in Tuticorin or Cochin, and I want to bring the samples to Mumbai laboratory. So by the time I bring it here to Mumbai laboratory, because of the transit and the time, the sample can dry out. To not permit the drying out, you actually pour the wax on either ends. Okay. Then the third one. 1 second. I think. First, we will take for field permeability test. A permeability test is typically checked to confirm the permeability of the soil below. So you drill a hole, just like in a stage 1, before conducting the SPT, we had cleaned the hole. Then you open a test section below that for a length L, which is defined as a 50 centimeter or so, and then you pour water on top. The water drop actually is checked over a limited time period of 5 minutes or 10 minutes, and then you add water to the same hole and find out how much water volume of the water is gone. So using this as an information and using the suitable equation, you can actually estimate the permeability of the soil. I'll go back to the rock drilling this thing slide now. You can see here that after you drill through the soil, you will end up drilling in the rock. It's a very common thing in Mumbai particularly. So guys who are watching this should know this, because most of you are going to likely to work in Mumbai. So in Mumbai, supposing you'll see that you will actually end up doing rock drilling. And in rock drilling, I'm sure these two terms, core recovery and RQD, actually you are familiar with. They are part of your course work also. So in the core recovery, the total drill run length and the total length of the cores collected is actually summed up, and that ratio is called core recovery. So total length of the rock cores, maybe there are 7 or 8 or 9 or 10 number of rock cores. So summation length of n cores divided by the length of drill run becomes your core recovery. Out of this cores, you will see that in the picture also, the top one has got a length of 250. The second one has got a length of another 10 centimeters. Then we have one of 190 millimeters, 190 mm, not 190 millimeters. These three pieces actually are more than 10 centimeters. Now these three pieces actually are summed up together again. Take the total of that three lengths, and summation of the lengths of the rock cores having length more than 100 mm divided by the length of the drill run becomes your RQD. RQD indicates how massive is the rock. How core recovery indicates how continuous is the rock. And RQD says how massive is the rock. How strong is the rock. Because lesser number of fractures indicates stronger rock material. Okay, so we'll go to the next slide. Just to sort of, when you go to the site, you should know that on the right side, this is a core barrel. You see inside here, there is a spring actually placed inside, and this then drill bit is actually attached. Now this drill bit actually is not a standard drill bit. The standard drill bit will be this surface set bit, it is called, which is a diamond studded bit. These are the water channels. You can see that they are water channels, and these are the diamonds are studded into the matrix here. And this diamond actually cuts through the rock. Now you will ask me the question, why is this provided in a very hard rock like quartzite or in a very hard granite? More number of water channels are required, and V grooves are done in this. Now the V grooves on the channels actually provide faster drilling speed. So these are typical introduction of the drill bits and this thing. They are used. You'll be seeing this physically at site also if you happen to attend and see what is used at your site. So field permeability are done. Okay. Now now we have seen direct method. We have seen semi-direct method. Now we're going to indirect method of this thing. The first indirect method of this thing is a method is a sounding. What is a sounding? Sounding is uh, we in India we call this as CPT or SCPT. It is static cone penetration test. Otherwise, it is called as a SCPT. Sorry, CPT. In international code market, we call this a cone penetration test. What does the cone penetration test do? You can see a typical photograph on the right side, where there is a hydraulic actually
शाम को लेके आता हूँ ना फिर
jack actually. The hydraulic jack oil is supplied, and hydraulic jack actually presses this down, and the resistance encountered actually is measured on the gauges. So you attach a lance or a cone or sitting cone. The sitting cone actually has certain dimensions, a certain angle of taper, and then you push this down into the soil, and the resistance encountered by this cone while pushing it down by under hydraulic pressure is actually measured on the gauges, and this is recorded. So for every 10 centimeter or 100 mm, you go on measuring the resistance and you go on adding. So this is a this gives you a continuous profile of the shear strength of the soil. What is DCPT? DCPT is nothing but use the SPT hammer, but a cone. A cone which is shaped somewhat similar to this, and a rods, SPT rods. So if you use them, then the test is called DCPT, dynamic cone penetration test, and static cone penetration test. Okay. So this is the first method. When the method is indirect, samples will not come out in this case. You are directly recording the resistance encountered, and you are processing. Okay, this can work as a, supposing we have a large site and we are constrained to use a few boreholes, let's say 10, 20 boreholes. So in between boreholes, if I use CPT, this data also gives me a very good idea what kind of correlation I can develop, and you can say continuity of strata or variation in strata can be located by CPT test. Then there is another method of indirect testing, which is a geophysical method. In this, electrical resistivity test or ERT, seismic resistivity test, the second one, and third one is sonic logging. Now, sonic logging and SRT is not done very regularly, but ERT is something we do regularly. So we are just talking about that first. You can see in the electrical resistivity test, you have 4 electrodes. They are driven up to say something like 1 foot inside the ground, and 300 1 second. 300 mm inside the ground. These cones are driven, once they are driven 300 mm inside the ground, middle 2 cones are actually connected to the voltmeter, outer 2 rods are connected to ammeter, and you measure current in the outer 2 and voltage in the missing 2. And the likely current flow, likely I'm saying, this is a guesswork, this is indicated in the diagram shown in the section. And you tend to measure the resistance of the strata. So in the first one you can see the strata resistance of the layer 1 is measured, and then the composite resistance of layer 1 and layer 2 comes in these readings. Okay, so this is another method of handling our indirect method of handling the investigation, in which you can get ERT. But ERT will become ineffective, particularly when you have a high water table or after rains, because after rains the whole thing will become saturated, and the voltage will drop down to a very low value, so resistance will become very low. Therefore, ERT is done pre-monsoon more reliably. Post-monsoon, it is not advised. one more thing. ERT is also used for
आपको मिला कि नहीं जब
water divining. You can actually determine the depth of the water table by using the ERT. And ERT also used for deciding the grounding potential for all your electrical installations, like in a substation or let us say in your office. Suppose you have a load of something like 5, 6, or 7 kW load, and you want to ensure that there is no reverse current coming back. So you actually conduct ERT, find out the depth at which you can take the earthing elements and actually earth it completely there, so that you don't actually get any untoward behavior of the electrical equipment in your building. Now the verification methods. The verification methods are once again PLT, block operation test, and ERT. Once you take a call, yeah, I want to place my foundation at 1 meter depth or 3 meter depth or 4 meter depth, I can reconfirm the capacity of the location by conducting a plate load test. What you are seeing is a plate load test. So at the test required, as required meaning, let us say that I want to conduct test at 2 meters. So the 2 meters is as required depth. I can place the plate at the top. You can see the plate here on the left hand side. Circular plate or a square plate can be used. You can use
क्या किया
sturdy reference bars on the sides, and they are supported at very far off points outside the influence zone of the plate. And then you can take the readings of the plate, settlement readings, using at least 3 dial gauges. In this case, they are showing 4 dial gauges, which is a better situation. Okay, so here we typically show 2 because the 2 are possible in the diagram, but it is desirable to use 3 or 4 as the value for the as the number of dial gauges for recording the settlements, because 3 defines the plane, and plate sometimes tends to rotate, and when the plate rotates, 2 dial gauges will not give you adequate results. I'll take a small breather for a minute.
Yes, sir. Please.
Yes. Now, what we are
Because
going to do is,
almost you are continuously speaking for 1 hour.
yeah,
Sir, in between, there are some questions which have come in chat box. So,
yes,
shall we take
we
them?
can speak about that. Yes.
Yeah. So I'll just read out the questions for you one
Yes.
by one. Maybe you can take them one by one.
Yes, please. Tell me.
Yeah. So I'll start with there is a question by Mr. Ashish who is asking how will AI affect the geotechnical investigation. So probably we can take it at the last, or would you like to answer, sir, now?
Okay. See, AI can, artificial intelligence can help you in standardizing the situation cases, but what tends to happen is, what we see actually is, uh, see, it is. I'll put it like this. I'll give a very different reply to this. Typically, when you buy a ready-made shirt, your sizes are fixed and the different measurements are fixed. There is a chest, shoulder, sizes, sleeves, length of the sleeve is fixed. If you take if you make the genetical changes, supposing I go to, let's say, Japan, or I go to Thailand, or the people from with the, let's say, who come from Mongol genes, they have somewhat shorter arms, shorter hand lengths. So their hand lengths actually are different. Now, unless and until that can be incorporated, those site to site tailor-made changes, I mean, every site is different for us. We have not seen in my entire career 2 duplicate sites. As a result, what happens is generalizing it completely would make it very difficult. Though, I'm saying though, report writing can be pushed into AI. I mean, we actually have done it. Our formatting is so good that even a 10th standard pass student can actually write my report up to 4th chapter. Only the assessment part is the job of the geotechnical engineer. So when you come to discussion about the foundation and assessment, my input starts there. In fact, in my office, I don't actually contribute much till that point. I start contributing my experience because which is a tailor-made experience. Every time you have to review the situation and then start contributing. So AI will definitely help in streamlining it, but final decision probably will be a human.
Okay. Okay. Yeah. There is a second question, which is saying, is IoT useful for geotechnical investigation?
Repeat, please.
Is IoT useful for geotechnical investigation?
Sorry, I don't know what is IoT.
So even me, I am not clear. So I'll take a next question. Mr. Abhijit Gawai is asking,
Huh.
how early should geotechnical investigation begin in the project life cycle to avoid delay in design?
Okay, it is like this. Supposing how early? See, okay. See, the issues before starting the project are techno-commercial. They're not technical issues. They're mostly socio-economical issues. Supposing I buy a plot, the person who is the buyer of the plot doesn't necessarily have access to the plot. Ideally, what should happen is Ideally, what should happen is to buy the plot itself, I should be able to conduct the investigation, some exploratory
Mm-hmm.
investigation. Supposing I get a plot A somewhere or plot X somewhere, and that plot X, is it suitable for my project, or am I going to end up with a very high foundation cost? If I can assess that beforehand, then only the question, Mr. Gawai's question, becomes very important, because then I know that whether I should buy the plot or not. That is the first question. Second thing is, once the plot is purchased, once the external influence or the interference stops, either political or social or economical interference stops, the first activity should be topographical survey, and the second parallel activity can be geotechnical investigation. I can give you an example. One of our clients actually were doing a pipes project actually in Telangana. In Telangana, actually, that was a plot next to the main road or highway, and rather large plot, something like 25 acres. And there, the topographic survey as well as our work comes together. And by the end of 45 days, we were able to give him the topographic survey data above ground and below ground investigation data within 45 days, and the project took off very fast. So the ideal thing would be that as soon as you purchase the project or purchase the location, you can conduct. But consider a situation in city. For example, supposing you have agreement with some society X, let us say whichever location it is, then you have to vacate the building, you have to demolish the building, and then start it. But many times we actually advise, once the building is actually vacated, the demolition activity takes some time. So we will not do investigation work along with the demolition because there can be accident. But we can do in between. That is, once the tenants are vacated and before demolition is the perfect and ideal time for conducting the investigation. But if the structure is sensitive, it's a very important and tall structure, then after demolition. I hope I answered at various aspects. Hello, Mr. Vivek.
Sir, you have answered it very well along with your experience, sir. There is a next question. I think we will take one more question and then we can resume back to the
Yes, yes, yes,
session.
yes.
There is a student of IIT Madras, Mr. Piyush Dalmia. He is asking one question. If a project timeline is in years and during construction of properties of soil change due to some unforeseen situation like excessive rain, earthquake, nearby construction, etc. How do we tackle such situation when foundation and some portion of the superstructure is already built?
Okay, that will depend on the uh, importance of the project and client mindset. I'll give you
Maybe,
one
sir,
live example.
in a big dam project or in a big maybe
Yes,
bridge project, this may happen, which
yes, I
runs
can.
for
Actually,
years.
I'm going to share an experience of that type only. Okay, so we actually were visiting a site in actually Himachal Pradesh. It was upstream of Bhakra Nangal. We are actually in the backwaters of Bhakra Nangal Dam.
Oh,
We were traveling from Bilaspur and we were going there. And what we went to the site for just to sort of examine that. A bridge was proposed across that water body, and there was an anticline, or you know the word anticline? It's an
yeah, yeah,
anticline
yeah.
is a geological formation, and on one side, the one abutment actually was sitting on a very good rock, a plain rock, but the opposite side was sitting on an anticline.
Okay.
And that anticline actually, during the earthquake, moved. So three-fourths of the bridge
Oh,
was constructed, and we were not able to get the alignment. The abutment in the front side shifted by 2 meters.
oh,
So this actually really did happen. It's good that Mr. Dalmia brought this up. It's very
oh,
interesting situation, but then it did happen. So we had to make curve the bridge to meet that situation.
oh,
So the
okay.
end of the bridge actually was turned to meet that road. So this is a very unique situation. It can happen once in a while. Doesn't happen always, but then
Yeah,
such a situation can actually happen. Second thing
yeah.
is that consider a situation that let's say that I've started a project. I can give you another example like this. There was a project in one of our outer suburbs of Mumbai. Uh, a project was planned, piling was carried out, and what happened was that the municipal regulations changed.
Oh,
Because of
okay.
change in corporation regulations, the structure became untenable. It was not feasible and not economically possible. So
Hmm,
the
hmm.
client changed the structure itself. So the job was they started asking us, can I use my old piles?
Oh,
So we actually checked the locations of the piles. We
hmm,
surveyed the locations.
hmm,
After surveying the locations and after taking the new layout, we selected some piles that can be used,
hmm,
and we removed or we discarded some piles and we added some
hmm.
piles. So for
Oh,
the change column layout, we had to do this kind of adjustment. We can call jugaad in the site language, and then we reconstructed a structure. Now it has come up today.
okay.
So such a thing is also a structural hack, but it requires a lot of help from structural engineer. It is not a
Yeah.
work of pure geotechnical engineer because the analysis became very critical in this case. Which piles are loaded, which are not loaded, and the piles which were discarded were cut well below the pile cutoff level, and they were not allowed to take any load at all.
Oh, okay.
So such a thing we actually have physically executed. This did happen.
Must have been a very rigorous and challenging work
Yes, it's
then.
a very exactly time-consuming, challenging.
Yeah.
Um, and actually, one such similar situation is at the moment going on in Mahim. The client
Okay.
actually is in dilemma as to what to do because the cost of that adjustment of foundation is going to be quite high. So he's wondering what he should do. So that is in
Okay.
the discussion mode.
Okay. Yeah.
Okay.
I think, sir, we can now resume back to
Presentation.
session. Yeah, because there are a few more queries, so I will take it at the end of the session.
By the way, what was IoT? I don't know.
Yeah, I'll ask the guy. He is not mentioned. I'll ask him to put what is LOT or IoT something which he's asking. So you may please start continuing, sir.
Okay. Um, all right. So, see, okay, you can say, look at the students today should look at me as a old piece who doesn't understand quite a few things online. And I started my career in 1982. So there were no computers actually as such. Very PC 80 was there actually at our time. And we have actually grown from PC 80 to slowly towards the laptops.
Okay.
Okay, so our progression is slow. And if you ask me in terms of short forms like this, probably I will not be able to answer at all.
Yeah, this man has given a clarification. IoT means Internet of Things. So I'm not sure what he's meaning exactly, but Internet of Things. So I'll just put the question: Is Internet of Things useful for geotechnical investigation? So probably Probably he means that something is available on Google, so you just take it and use it in your investigation, something like that.
Okay, Internet of Things meaning if it is a interconnecting the various aspects of the geotechnical
Okay.
investigations by using sensors or by collecting data or things like that, then
Okay.
the what tends to happen, I think the person should realize that we tend to demolish the entire ground first. We excavate the
Hmm.
ground, right? So we take out everything. Once we take out everything, we need to actually understand and monitor the subsurface conditions. The monitoring is possible only after you place the foundations.
Hmm. Hmm.
Let us say that I'm having a structure in a very settlement sensitive area, and or the structure itself is uh, settlement sensitive. Then the real time monitoring of the such a structure on a standard time duration, let's say 24 hours or 6 hours or 8 hours or whatever it is, would be required, and the surrounding activities, how it responds to that, also would be monitored. Once
Okay.
that is done, then probably, but geotechnical investigation, what we are now discussing, is very primitive, and
Hmm.
we can go to that, but that is a
क्या आ रहा है बीच
I would
में?
use the word kind of sophisticated for the what we are discussing in today's proposal, today's discussion.
Okay.
Um, really speaking, because my idea was to give just an overview and introduction to the person or to the team,
क्या है
and
यार?
not get into sophistication of it. This can be
Yeah.
done on a person to person basis if the person actually wants to take up geotechnical investigation as a profession. Okay, but that's a different thing altogether, isn't it? Isn't it?
Correct. Correct. Understood, sir.
Yes.
Yeah.
Right.
You
Okay.
can continue with the
Now we go to
PPT.
steps in investigation.
Yeah.
Are you able to see my presentation shared?
Yes, sir. Yes, sir. It's
Right. So let us
visible.
start. So the water diagram you are seeing actually was the one that was this rig. This is on the left hand side, the yellow colored rig which is there with the two humans standing there. This is what we are going to use, or we are going to discuss here in this presentation. So the basic rig with tripod. You can see that there is a differential gear actually, the differential gear which actually rotates a square bar. To the square bar you attach drilling rods and send down the drilling cutting bit a little bit down into ground. To once you start cutting the soil, you will find that you to make the space for further progress, you need to bring out the cuttings. So if you bring out the tool every time, you will find that the soil will collapse. To prevent the collapse, you actually send water through this mud pump. You can see the line, and there is a swivel at the top. This is a swivel. It goes through the central Keli. The water goes all the way down, and then comes back from here. Comes back, comes out of the casing here, falls here. It goes into the return flow. It is corrected in the ditch, goes into settling pit again, and goes to the main this thing again, main pump again. So from here it is pumped back. So the same fluid actually is repeatedly pumped, and whatever cuttings are actually brought out are collected. Sometimes, or quite a few times, you also collect sample from here as a disturbed sample. Whatever comes out and deposits at the site is collected as a disturbed sample. So the SOP or the standard operating procedure would be: you set up a drilling rig by making the ground level. You start boring into the overburden soil using the calyx bit. When you reach required depth, let's say 1.5 meter, 1 meter or 1.5 meter, you can conduct your first standard penetration test. You collect undisturbed soil sample. You can also collect undisturbed soil samples after undisturbed soil samples, particularly in cohesive soils. Undisturbed soil samples are not possible in sandy soils, mind you. Remember this. At least that technology is not come to India even now. And then once you hit the rock soil junction, you start drilling in the rock by changing the bits. You saw that the diamond surface set bits there. Actually, remember that again. And then you start collecting rock cores. Then During the course of the work, you will hit the water table, and that water table actually will manifest in a extra quantity of water that will come out in the return water. So that ground water table is determined. You have, and then finally collection of groundwater sample. These are the activities that are performed in the field work. Okay. To show you typically, in the collection of samples, we are showing you two cases. Representative sample of each layer is collected for the lab testing. You can see the SPT spoon is actually opened up here, and the soil sample is collected in this spoon. This part of the sample is placed outside, and this is the shoe actually on this side, and this is the head. And on the other hand, the undisturbed soil samples, the shorter chrome plated UDS tubes are used. Chrome plating is done to reduce the friction, and these are placed inside the extractor, sample extractor. You can put two tubes together, and a ram is pushed from down below, and you can get soil sample is collected inside this. And you can see the extractor sample is placed outside the clay samples. So you go to lab testing now. After the field work is done, the test on soil are grain size analysis, attribute limits like liquid limit, plastic limit, and so on, specific gravity, swelling index for the black water soils, to determine the shear strength, direct shear, triaxial. Triaxial is a right side machine, is a triaxial machine. You can conduct 4 types of tests in that: UCS, triaxial unconsolidated undrained, triaxial consolidated undrained, and triaxial consolidated drain test. All 4 tests are possible in the same machine. Then what we are not shown is the consolidation bank here. Consolidation you must have seen in the laboratory, and compaction, which is used for road pavement or the plinth filling and so on and so forth. You also conduct test on rock. For the GSA also you can use this hydrometer, which is you can see on the hydrometer actually used for separating silt and clay fractions. In the test on rock, you take the rock piece, cut it in as a cylinder, and then you conduct this test: porosity, dry density, water absorption, unconfined compressive strain in saturated condition. And if the piece is very small, less than 2 times the diameter, then you conduct a point load test. You can, for special cases, you can conduct elastic modulus, and also can determine petrography if you are interested in finding out what are the mineralogical contents of the rock. Finally, the basics of chemical analysis of water and soil will be pH. If the pH is less than 5, the soil becomes acidic, and you cannot cast concrete in that because ettringite will form. Then sulfates, chlorides. High sulfates will be damaging to concrete. High chlorides will be damaging to the reinforcement steel, and organic content will be damaging to the set concrete. So all this actually have to be checked and provided in the investigation report. So basically we have seen what all goes into the investigation. We'll go to stage 2, the interpretation of the geotechnical data. In the interpretation, now we are coming to the fag end or the last leg of the presentation. For interpretation, what you do actually is you have data obtained from the field, and you have to conduct a lab test. Now you are trying to put the whole thing together. So the typically filled up soil is a strata on top. Then there is a cohesive soil. There can be a non-cohesive soil or sandy or gravel strata. It can be either cohesive soil or non-cohesive soil, and followed by completely eroded rock. Completely eroded rock is a technical name. You can simple language you can call it murum, and it is followed by rock. So the property of each of them are we are going to determine by conducting the above test. All these tests we are conducting, the GSA, grain size, EU, and all that, and you get the shear strength and consolidation will give you compressibility. Okay. Then next is you conduct a test on the rock mass, parameters of rock mass. To determine the rock mass parameters, remember we defined core recovery. So degree of weathering is based on the core recovery. Supposing the rock mass is continuous, 100% core recovery, nearly 100% core recovery there, the rock mass will be fresh to slightly weathered. Then the core recovery is between 50 to 70%. You can say it is moderately weathered. Then the core recovery is less than 50%, but more than 10%. We will call it highly weathered. The core recovery is less than 10% or up to 10%. I will call it as a completely weathered rock, Muru. And sometimes the core recovery is zero, but it has got a look of a rock mass that is called residual soil. So these grades actually 6 grades actually are visible in the rock core recovery. Then the frequency of natural joints actually also is a idea. It gives you idea of the massiveness of rock. So 0 to 25 very poor, 25 to 30 poor, 25 to 50 poor, 50 to 75 is fair, and above 75 is good. So 4 qualities are mentioned there. And then the strength of rock core is one more parameter. So we can have, let's say, starting from very strong rock above 50 MPa or 500 kg per meter, 500 kg per cm square, 500 to 125, 125 that will be called strong rock, 125 to 50 will be called weak rock or moderately weak rock, 50 to 10 will be called weak rock, and below 10 will be called very weak rock. So these are the classifications even in that. So using this, like suppose you take a tooth rock which is seen in Mumbai, it's a weak rock with a 5 to 7 MPa crushing strength, but the core recovery can be 100%. So we have very high core recovery and low crushing strength. And on the other hand, we can have very strong basalt rock with a crushing strength of 50, 70, even 100, 130 MPa, but the core recovery can be very low, like 10, 20%. So these such a ends or variations are possible. So it is not necessary that you have a very high core recovery means you have a very high strength. So strength comes from the mineralogical composition, and recovery comes from the weathering. Okay. So these three parameters chiefly define the classification of rock mass. As I emphasized earlier also, the water table is a very important object. It is subjected to seasonal variations, and when you do investigation, you get some water table, but that is indicative of the water table and in that season. The highest water table that will be recorded will be only the heavy rains. Typically what we have seen in Mumbai is that the water table rises by about 3 to 3.5 meters above the off-season water table. If you go to a place like Ahmedabad, some of you might be there or must be seeing it. What we have noted or seen is, if it rains, a sharp shower comes, you will see a water level up to waist height, and then because the drainage is poor, city drainage is not very good, so there is water logging on the surface, and next half an hour, because the strata is sandy, the water goes down. So the effect of highest water table for the design will be the one that is recorded in the even in a short rain spell. And that is the point I want to make in this case. So that should be taken as a design water table. So I am showing you a typical borehole which is come out of the investigation. You can see on the right side there is a borehole number, and the termination depth of borehole is 15.8 meter. The casing which is required for unstable strata is up to 5 meters. Commencement date is 2/4, say 14, and the end date is 4/4. This is the actual borehole which you have drilled actually in the past. At some sites there are coordinates available, some sites there are not. So whenever the coordinate is available in northeast, we provide coordinate. The ground level, location, meaning in a given plant or a given location lift. Let's say in the residential building in the lift area, or the north point, or in the, let's say I'm in the industrial plant, then I can say a dispatch area or the warehouse, or that location is mentioned here. Diameter of the bore is mentioned, and depth of water table 4.10. You can see on the right side there is a water table here and water table here. So what are different layers seen within the borehole? You can see bit of soil. Bit of soil actually is a material brought from outside and deposited on the ground to level the plot mostly. The second layer is a first virgin layer, virgin ground level, yellow stiff silty clay with some N values. You can say stiff because N values are more than 8, so 12, 14. It is followed by murum strata, completely weathered rock with a low core recovery, no arcady but low core recovery. Once the arcady cross 10, then calling it highly weathered rock, going up to 7.5 meters, and below that the core recovery is more than 70-80%, so we are going to slightly weathered rock. Okay, and on the right side you can see the different depths are marked in a borehole. These are important things which you should note in your report whether these are presented. The reduced levels are also marked at the junction of every strata, and the tests which are conducted SPT1, SPT2, the first 15 centimeter, second 15 centimeter, third 15 centimeter. You can see 5 plus 7, 12 is reported here, and 6 plus 8, 14 is reported here. And in for this case, the refusal is met with immediately because rock, bedrock was met with, or maybe gravel was met with. So 32 blows for 15 centimeter penetration, so refusal. That way we are moving ahead. Typical core box, as you can see here. These are mostly basalt cores. The bottommost one, the first one you see, a very good quality rock. Long cores, you can see, very high RQD. Long cores means length more than 10 centimeter. That means very high RQD value here. Then you can go to the next box. The color has changed, you can see, but this is still basalt. And at the upper levels, up to top 6-7 meters, you can see rock is fractured, very badly fractured. Very badly fractured. This pocket actually here shows that there is a problem in water loss here. Very poor recovery here. You can see the rounding of the surface in the. If you can see the rounding of the surface here, it indicates water flow here. Then you go to the top box. You can see in the top box there is a very poor patch here. You can immediately tell me that okay, yes, this is a water loss area. Water loss area. Then followed by rock, and you can see some soil stratification here on top. So these materials are available to you for your. Okay. Next. So how do you analyze? So using this data, you generate a subsoil profile. You classify subsoil layers using in situ values. We'll show you the subsoil profile next slide, and I might as well show you that. Okay. So we have 3 borehole profile here. So you can see RL 102, 102, and 100. Layer 1, layer 2, layer 3, and major slightly weathered basalt here. So based on this stratification, you can say where am I going to put my foundation? You can come up with that answer. So layer 1, I will find out the properties and decide whether I can put my foundation here. Check the properties of this and see whether I can put my foundation here. You can see there is a low recovery here suddenly 0, 0. So this is unreliable strata. Same is 18, 0. You can see also see 0, 0 here. So this layer is not satisfactory. So I should take my foundation below, right? So the best strata would be to take my foundation at this level. I should take here either that layer dips. I cannot place it here at 9, 0. So I have to take my layer. In this borehole 2 and 3, the depth would be about 91 RL, and in this case it will be go down to 85, 86. Okay. So that's how you select. So check whether each layer from top towards is capable of carrying the estimated load. Calculate shear strength. Calculate settlement. Use smaller than 2 values. We will go to this. There is a flow chart we have made for this. Decide what is a suitable stratum and decide the foundation depth. Okay. So for doing the interpretation and selecting design parameters, what do you do? So this is the basic design principle which you are doing for structural engineering also. So you estimate the characteristic load maximum coming from structure, work out the worst load combination, and multiply this by load factors and say this is the ultimate load I will get at my site or my structure. And then you use this method for, let us say, for concrete. Estimate the material strength, apply material factor of safety, compare to make sure that the material strength is more than the expected loading. Now, this material strength is normally called the FCK, characteristic strength. Is there something called FCK for soil? The answer is no. The answer is that for the number of, because in the concrete actually, or in the concrete casting, you test number of cubes, not one. At one batch you test 6 cubes, and you go on testing cubes like that in the quality control, and so you have very good idea how much is the minimum material strength or you have defined it beforehand. In case of soil, it is as it is where it is. So because it is not in your control, it is a God-given thing. It is an existing soil material. So the minimum strength from the 2 boreholes, 3 boreholes, 5 boreholes, 10 boreholes, whichever is the least value is what I will select for estimating the material strength. Apply a factor of safety on that, and then I will use this value as a safe value for SBC for estimating the SBC. I hope you understand the logic here. Okay, so how do you look at this? So once the foundation is taken, you have a data from soil design parameters. You have selected C5 value and density value, as we said, from this the least possible value, and then you come to this condition, and then you determine for a given depth the ultimate bearing capacity. For determining the ultimate bearing capacity, you know that you have studied Kazak's bearing capacity equation. You use that, use NC, NQ, and gamma, come up with those values, apply a factor of safety on that, and you come up with the safe bearing capacity value. The word is safe bearing capacity, I'm repeating. On the other hand, using the E value and the other parameters, the compressibility parameters, E, mu, and nu, and M and N is equally mu and nu. The parameters are theory of elasticity or the lab tested parameters. You can estimate the settlement for a given foundation type. Using the load increment, what you are planning to put on the structure or the foundation strata, you estimate the likely settlement. If the settlement is within your permissible limit, that is a limit permitted by structural engineer or structural design, that is you know the limiting values 1 in 250, 1 in 550. Normally the limiting settlement, differential settlement is 1 in 500. That is the best value which normally taken for very good performance of the high value finishing. Now this value is called allowable bearing pressure. So on one side you have safe bearing capacity, on the other side you have got allowable bearing pressure. On allowable bearing pressure, the factor of safety is 1. There is no factor of safety on that because it corresponds to the permissible settlement. And in case of shear strength, because shear strength is value estimated as the ultimate value, I apply a factor of safety on it. So I compare these two things. One is the factor of safety of 3, one is the factor of safety of 1. Takes one of the two values and I call it as a safe bearing pressure, not capacity. So safe bearing capacity and available bearing pressure are fused together and are called safe bearing pressure. Now this is that is what is used for designing the foundations. Okay. So just to go now, this is a very simple thing. There is the common sense thing. There is nothing more than a common sense in this slide actually. You have done the investigation, you have done the interpretation, and you have come to conclusion. So the first choice is, of course, isolated footing foundation. And if isolated footing foundation cannot be designed for given loading, then I will merge 2 footings, 3 footings, and make a combined footing. If the columns are close by and the footings are overlapping, then I will go for a combined footing. And I can still keep isolated footings for remaining columns, which are far apart. If combined footings are also not possible, if consider the combined footings are in a line, then I can construct a strip footing. Maybe in a plant or steel in an industrial building is very much possible. And if large number of footings are getting merged into each other in both directions, and the configuration is favorable, then I can use rough foundation. So I have isolated footing foundation, I have combined footing, I have strip footing, and then I can have rough foundation. Now, if the load carrying capacity of rough foundation is still lower than the required capacity, remember, the moment you decide to construct bigger and bigger rough, the zone of influence increases. The permissible settlement will still remain the same. The value doesn't drastically change. My footing size, typically you go up to 3 meter or 4 meter by 4 meter. For 4 meter by 4 meter footing, the permissible settlement may be 25 or 40 mm. But for a raft of 10-20 meters, the permissible settlement is only 75. It doesn't increase in the same proportion. As a result, the allowable bearing pressure of the raft is lower than that of the footing. As a result, you might actually end up having raft capacity lesser than what is desirable. In that case, you go to pile foundation. If you go to pile foundation, then mostly you can manage the thing. But if the pile foundations are also not sure, not giving you good proper performance, then you can ultimately go for a well foundation, like in case of marine structures, or like in case of bridges, or very rarely for other structures. Like Taj Mahal, you might be knowing that Taj Mahal has got well foundations, just as an example. Okay. So the concluding remarks from my side are: good quality and reliable investigation data is must for sensible interpretation of results and selection of design parameters. Due to inbuilt inherent variations in the subsurface ground conditions, selection of optimum design parameters is should be left to experienced geotechnical engineer. And maybe here, I don't know how much AI can do for you, but maybe AI can do some help here. When the data scatter is large, in a data scatter, supposing I got 50 more holes and I'm selecting a foundation at 3 meter or 4 meter, and I got a large data scatter, and I can select using AI here. And a foundation either in soil or rock under different conditions can be designed by optimizing design parameters. It will be necessary by selecting design parameters that constructability, can I actually construct the foundation which I am proposing, should be also duly considered. If that is not done, then probably you will end up with the impractical foundation. With this, I conclude my presentation, and I would request questions from you all. Thank you.
Wow, such a wonderful holistic view, sir. I must appreciate, because to cover the entire topic in 1.5 hour is really a tough job. So there are a couple of questions for you, sir.
Yes.
There is a first question in continuation. Mr. Shailesh Shinde has asked, what is the difference between the role of geotechnical engineer and a structural engineer in design of foundation?
Okay, I'll give a very simple answer to this. Consider that Vivek Abhyankar is a structural consultant and Shekhar Vaishampayyan is a geotechnical consultant for a given site. So our roles are different in this. How our roles are different? So for a given column configuration, the loads, moments, and the lateral loads at the top of the pile cap are known to Vivek Abhyankar. That I did not know them. I can define the geotechnical capacity of the pile. I'm using the word geotechnical capacity of the pile below the ground. So Shailesh would know probably that when the load passes from the column to the piles, it doesn't carry the moments because the pile caps are very rigid. Only the lateral loads and vertical loads will pass through, and the moment induced by the lateral loads acting on the pile cap, the top of the pile cap only will induce more moments will be there. So the role of the geotechnical engineer is to provide you geotechnical design. It should give you the length. It should, but it may not define the reinforcement in the pipe. May not. It can. The geotechnical engineer can help structural consultant or engineer by offering a choice of using different combinations of structural reinforcement steel. But a final decision about placing the reinforcement will be taken by the structural engineer.
Right. Understood, sir. There is a next question by Mr. Guru Prasad. If we have to make a large number of boreholes or pits in the ground, would the effect of strength of the soil? If yes, how is the strength of the area digged and refilled or reclaimed?
Okay, I can answer the question in a very simple manner. Consider that I have a steel plate. Consider that I have a steel plate of size, let us say, 300 mm by 400 mm, a long steel, or 300 by 300 mm. If I drill a 3 mm dia hole in the plate, what is the reduction in the plate strength? Negligible. The size of the boreholes what we drill in the soil are 100 mm. Consider a plot. Okay, he should calculate actually himself. Supposing I got a plot of 30 meter by 30 meter, and I drilled 4 holes or say 10 holes. liberally I have taken 10 holes. 10 holes of 6-inch diameter. 6-inch diameter is 150 mm diameter. What is the volume of soil I have disturbed? You
Mhm.
find that the volume is so small that it will not affect at all. And if at all that is going to happen, then as a consultant, structural engineer or the geotechnical engineer should ensure that after completion of borehole, the bore can be filled back by using sand cement slurry. The matter
Okay,
can be closed there.
great, great. Yeah. Uh, the next question is by Mr. Ashish Meena. If he has asked in mountain region like Uttarakhand, Joshimath, where land is sensitive, how will you conduct any project and or do the geotechnical exploration?
Yes, how to conduct the investigation is not impossible. My friends actually are already doing it there. But then
Oh, okay.
basically what tends to happen in places like Joshimath or in Himalayas, upper reaches of Himalaya, is that we have somewhat unstable, geologically unstable formations there, which is known to us, Shivalik ranges. What tends to happen there is that the water or the subterranean water becomes a very critical factor. And
Hello.
as I said in one of the slides, the access to the equipment becomes a very critical issue.
हाँ बोल.
In such case, we have a somewhat larger labor team and people take the machine by head loads,
खुदा चाहिए इसका.
Oh,
and the shifting of the machine itself takes maybe a month. So we are taking a point to a point, supposing I'm taking it 100 meter or 200 meter above. So people have to climb down slowly, climb up, taking the pieces of machinery there. Then they level the thing at ground at a given location. See, let us say you're conducting a hole, carrying out drilling a hole for tunnel, for example.
hmm.
So this is required and it is done. So when the unstable formations are there, the unstable formations doesn't mean that it is going to come down tomorrow. Landslides will happen, but landslides always happen when there is a accumulation of water pressure. So
Hmm.
if you can, by sensible methods, you can release that water pressure from location to location. The landslide problem can be alleviated largely. The point what tends to happen is when the so-called development takes place. I'm calling it so-called because the development becomes indiscriminate and everybody has got right to do his own thing. So people do actually things in an incorrect manner. As a result, what happens is the water paths are blocked. If you block the path, water is going to find its own way somehow. You
Hmm.
can't stop it, or it will create a massive hydrostatic head, which is actually going to contribute to the landslide failures. If you can always make sure in your life, say to water that my dear water, you are a boss. I'm providing you a drainage path. Release the pressure. If I release the water pressure, then the problem can be resolved.
Okay,
But investigation
okay.
is done for tunnels. It is done for roads. It is done for various other things.
Yeah, yeah. So there is a next question. Sir, you have time because there are two, three more questions. So
Yes,
I'll
please.
just take,
Oh,
yeah.
we'll do it. We'll do it.
Uh, so there is another question by Mr. Tulsi Ram Gali. He is asking on dam construction, the rock contains different minerals which react with concrete. How do we make these minerals non-reactive in nature? Does the low heat generation cement help with such reaction? So I'm not sure it is a part of geotechnical, but sir, you can answer it.
I'll try to answer this. This is not my field actually, but then this is going way outside my syllabus. But it is not the syllabus of today's presentation. All right.
Yeah,
But then uh, the minerals reactive to concrete, probably he is referring to alkali reactive aggregates.
correct.
I
Yeah.
think for using the alkali reactive aggregates, there are very defined methods are actually available in the literature.
Mhm.
So we should actually follow that. And for low heat for dissipating the heat in the concrete blocks or mass concrete, typically people actually have in the past have actually inserted tubes steel tubes inside the dam. These steel tubes actually they circulate water through that in the green concrete. When the concrete is green, and it is actually exothermic reaction is taking place for the to dissipate or the to sort of reduce the heat of hydration. Basically, water is circulated through that, and you take out the hot water actually, and
Okay.
that, that is one of the simplest ways of handling this. But then the other today what actually tends to happen is people don't go for this kind of huge height of concrete now. People are now saying that they will do concrete in layers of 1 feet, 300 mm only. If you use concrete in 300 mm layers and you roll it down by using your, instead of compacting it, you actually move road roller on top, fabric roller on top. So the heat of hydration actually is very limited.
Hmm.
That's called roller compacted concrete. It is used
Hmm.
actually. There's a, I think one of the famous, Michael Dunstan is one of the famous rolled grid concrete dam expert. He uses this technique. So the heat of
Okay.
hydration can be effectively taken care of. So no
Okay.
problem. You can either circulate water through the uh, uh, green concrete and take out the heat of hydration, one, and otherwise this. You also must be knowing that the iced aggregates as well as
Hmm.
water
Correct.
actually is also used in the concrete to sort of counter the effect of heat of hydration.
Yeah. Yeah.
Partially
There
answering
is,
this, not fully.
yeah.
Partially answered the
Uh,
question.
there's a next question by Mr. Akash Babar. He is asking how to convince client architect to go for geotechnical testing. Most of them are non-technical background and we are willing to and not willing to spend. The problem is more evident in small cities and towns.
Now that depends on your marketing skill. No, that depends on
Uh,
actually the structure engineer has got a unique relation with the client. He does, and that is something he has to establish also with the architect. This is human issue, not really a, shall we say, this is human issue, not our issue. No? This is not a geotechnical investigation. We can actually, what can be done actually is that I don't know where you are calling from or talking from, but in small places, ISSE can actually organize or arrange small presentations, and the
right.
presentation particularly related to the foundation failures. If that can be arranged and discussed and put across to architects as well as developers, probably the education and bringing them with the likelihood of failure is the only thing that will cause them make them alert, and I said sit up and alert them that okay, investigation is required and let us do it. Maybe do it
Yeah.
in a small way initially and then increase the scope later.
Yeah. Yeah. Definitely, sir. That's a very good suggestion from your side. I'll definitely speak with ICC president on this line about the foundation failures. Now, most of them, they are not questions, they are compliments to you, sir. Mr. Mohammad Nazim is saying very interesting session and for the thank you for the opportunity to attend. Mr. Sinvero is saying thank you very much, very interesting session. And Mr. Shinde is also saying thank you very much, nice session. Abhijit is saying thank you very much. How the way you explain geotechnical investigation is very easy to understand and really interesting. So I think with that, I would just like to conclude with whatever you covered in a small 2 minutes. I'll take. Sir, you started your session with a topographic survey. Then you covered if we bypass the exploration, then what would be the repercussion of that bypassing. Then in nowadays we are getting unacceptable or undesirable site locations. Then what to do? Then it becomes imperative to have geotechnical investigation. Then the reliability of the agency you spoke on about the geotechnical issues, then actual loads coming on the on the column, how to decide them, and then the parameters which you should decide as per the load for the exploration, then access to the drilling machine you spoke on the hilltop and all. Then you spoke about the IS codal requirements like 5 boreholes per 4,000 square meter and what to do with that as per the increasing height of the building. Then you spoke about the minimum depth of the penetration, like if the width of the foundation is B, then minimum 2B or little more. What are the key points to be taken in mind during that selection of the depth of the borehole? then number of boreholes plus number of flows, you showed the table. Then you started with the methods of exploration with the Calic conventional rig. Then you explained about the SPT, which was like 55 centimeter, 65 kg weight of the drop, how from where it is coming from. Then correlation with between SBC and the soil properties like SBC, safe bearing capacity, like that. Then you spoke about the loss of water during drilling and transit of the samples from site to the testing laboratory.
क्या होगा उसको?
Then you discussed in
अजय भाई
detail
पेट
about
हिल रहा
the
है
rock core barrel and why there are grooves for circulation of the water and how
है
more
ना?
grooves are required if the rock is very dense. Then you discussed about, sir, the direct methods like CPT, indirect
काम का पर
methods
हिला तो नहीं
like
ज़्यादा, थोड़ा ही
ERT,
हिलते हैं.
then sonic logging. Then moving ahead, you discussed about, sir, laboratory testing methods, petrology, how
आज
geology
काम नहीं है
also
लगता
comes
तुमको?
in between this geotechnical
लगता नहीं है
investigation.
तुमको देख के हंस रहा है,
And
नाच रहा
finally,
है,
very important point
पेट
which
हिला
you
रहा
have
है.
emphasized is the teamwork, importance of a collaboration between geotechnical structure and a client. They cannot work in isolation. All three are required to together. Then you emphasized on the high
इधर
core
अजय भाई,
recovery doesn't
पीपल के
mean
पेड़
that
का
the
देखो,
strength is
डैनी
also
कितना
high.
अंदर
That
गया है.
was another important point which was very important to note, sir. And then lastly, you discussed on the groundwater table and how are the samples to be correlated with the logs and actual site, then deciding the actual foundation from the interpretation of the result. So it was an excellent session. Thank you very much from on behalf of ISSE and student chapter. So we would like to see much more presentations from you in the coming future also. I think there are no questions from the participants, or because the chat box is now, I have covered all the questions. So I announce formal closure of this session, and thank you, Shekhar sir, once again. Thank you very much. Have a good day.
Thank you, sir. Thank you, sir.